Thanks for taking the time and joining us today for this DevLive Level Up event. My name is Manish Kapur, and I'm from the Developer Relations team at Oracle. Today, I'm going to talk about modern application development on OCI and how you can future-proof your applications. This is a high-level talk where I'll basically give you paint a broad picture as to what all services you have, what all tools you have as developers to build cloud-native applications, to build traditional legacy applications, to build low-code applications. So I'll give you a high-level overview of everything that you have, and this talk will hopefully set the context for the remaining sessions throughout the day and over the next 4 days. So let's get started. Oh, before I start, if you want to connect with me on LinkedIn or Twitter, my coordinates are up on the slide. Feel free to reach out after this presentation if you want to continue the discussion and chat about any of the things that we covered today. It is a golden age for developers. As developers, we have unprecedented choice of technologies and computing power at our fingertips. We have the choice of programming languages, frameworks, platforms, and with ChatGPT and generative AI around, there's lots of things happening in the industry. And we as developers have a good choice of tools, services, platforms to select from. You can imagine and innovate as much as you like using the services that you have at your fingertips. As developers, we have lots of choices to build applications. We can build microservices for sure, which is the cutting edge technologies like Kubernetes and serverless functions and DevOps and all of that. But beyond microservices, you have plenty of other choices. You can build low-code applications. You can build mobile applications. You can build intelligent chatbots. You can still continue to build virtual machine-based applications. As developers, we have lots and lots of technology choices available for us to build modern applications. Which application should be built using which technology? That's a question that often comes in. So how do you decide whether I should build a microservice for a particular application, use a microservices architecture for a particular application, or should I use a low-code architecture for a particular application? I'll try to clarify that and give you some help in terms of how you go about deciding which type of technology to use for building your applications. So as engineers, we often tend to focus on technology. It should be the other way around. We should focus on the business outcome and then determine what technology choice to be used for building that, reaching that outcome. Think the other way around. Instead of choosing a technology first, think about your business outcome, think about the application you're building, think about its requirements, and then select the technology based on your business requirements. Many of our design decisions today are based on technology trends. Instead of using a technology and an architecture pattern as the first starting point, you should really understand first what each technology does, what it tries to solve, what is the best use of that technology, and whether that maps to your use cases or the requirement that you're trying to fulfill. Another important piece of advice which I can tell you from my experience is factor the future state of your, in your design decisions. Think about how your application that you're building would look like in 3 to 5 years. Think ahead. You start small, and often your footprint grows, and in 5 to 6 years, you have a massive footprint. So think about the technology choices that you're making right up front before you start building applications. I often tell my customers to apply the KISS principle. KISS principle is supposedly something that the Army and the Defense Forces practice. It's keeping things simple. Keep it simple, keep it automation, include automation in your design, make it as simple as possible so that you can easily support and sustain your applications that you're building today for the next 5 years. Another key point is, I've heard customers who say, we have always done it this way, so we'll always continue to do the same thing over and over again. Continuous learning and continuous improvement is very important. Don't stay within your comfort zones. Try to adopt the new technologies, learn the new technologies, and use them when it makes sense. For example, about 6 or 7 years back, when microservices architectures, people started building applications using microservices architecture, the common design pattern was, let's have one best-of-breed database per service. Customers who took that journey and still continue to take that journey soon realized, like after 5 or 6 years, they've built a massively distributed architecture, which is very complex, which is very hard to manage, with 10 different databases, 10 different applications written in 10 different languages. So think about the choices that you make. So instead of doing that, there's always a better way to design your microservices, like using converged databases for building your microservices applications. This is a real example. A customer wanted to go serverless all in. They started the journey with a serverless set of applications, and over 3 or 5 years, their architecture looked like this, what you see on the slide. What they didn't think about was the end state. Where would they lead? What would it look like once it's all built out? So keep it simple, do it right, factor the future state of your application, factor the skill sets that you have within your company, and then make the right choices for your application. So when it comes to developing applications, there are 4 key patterns that I often see being used for building applications. The first one is, let me go back. In addition to building new applications, we also see customers moving their existing applications, extending them, and then building net new applications. They do take 3 paths. So if you look at the application development platforms on this slide, there are 4 patterns. You have virtual machine-based apps, microservices and serverless, and the cloud-native architecture deployments that you have. People are now using emerging technologies such as AI, ML, Web3, blockchain, 3D, AR, augmented reality, and embedding those into their applications to make the experience even better. And the last one is visual and low-code applications or mobile applications with minimal amount of coding. These are the productivity apps that you often build and you still continue to build. So I'll talk about all of these patterns and how Oracle helps solve each of these patterns in the next few slides. So Oracle has a complete application development platform for all the app patterns. So starting with the compute infrastructure layer, where we have, as Mahesh talked about it in his presentation earlier today, we have a set of compute and infrastructure services, deployment services, for building and running all your applications, whether they are VMs, whether they are serverless applications, whether they are containerized applications, whether they are microservices. We have a set of foundational services, Kubernetes, serverless functions, compute, everything that you need, which is built on top of the Generation 2 cloud architecture that we have. So as developers, we have the platform for deploying and building applications. Now what do you do next? You pick up the right language, the right tool for building your applications. If you are a Java developer, you would look at Java as your programming language, or look at Graal VM for building Java applications. If you're building a microservices, you would look at things like Helidon or Micronaut for building your applications. Once you have chosen the technology, the language, the framework that you want to use to build the applications, next what you want to do is implement a CI/CD cycle around it. So at Oracle, we give you a choice. We have an OCI DevOps service, which is a CI/CD service, which lets you do build and deployment of your applications with source code management built in. Everything that you need for CI/CD is built into the platform. Now we realize that customers have invested in certain other technologies like GitHub or Bitbucket or GitLab or Jenkins or something else. So the CI/CD service is very modular. So you can bring in your own set of tools that you're using, or use the tools that we provide for building applications. Now that you have decided on the technology framework and you have a DevOps platform, when you build applications, you want your applications to be API-driven. It's an API-first approach in cloud all the time. So we have a set of cloud services for developing APIs, publishing APIs, and using APIs, consuming APIs. And along with that, we have a set of messaging services and integration services to integrate all your microservices and serverless apps. So now that you've built the application or you're building the application, often your applications can be stateless, but they can also be stateful. If you need state, we have a set of data management services along with machine learning and AI built on top of our databases like MySQL HeatWave, as well as Oracle Autonomous Database. And then once you have built the application, you have a microservices architecture or you have a virtual machine-based architecture. What about the day two operations? How do you manage it? How do you observe it? How do you debug it? So we have a set of observability and management services that can manage your cloud-native applications as well as your traditional virtual machine-based applications. And then we also have security and governance services to manage the entire footprint of your application deployment, whether it's VMs, whether it's serverless functions, whether it's microservices. So let's talk about each of the 4 patterns that I started with, starting with virtual machine-based applications. How many of you are still using virtual machine-based applications? Can I get a raise of hands? All right, so we do have people still using virtual machine applications. And I don't foresee virtual machine-based applications going away anytime soon. They will continue to coexist. More and more applications will be cloud-native and microservices-based architecture applications, but virtual machines will continue to exist. In fact, if you think about it, what do containers run on? They run on virtual machines or bare metal compute. The fundamentals are still the same. So you will still have virtual machine as your underlying piece of technology where you run either your traditional legacy apps or you run containerized apps. So when do you use virtual machine-based apps? If you are basically using traditional legacy apps, if you have Java application server apps like WebLogic, WebSphere, Tomcat, or some of the apps which are hard to containerize, which are too complex, which you don't want to reinvent, the cost of reinventing them or rewriting them as microservices is too high. In those cases, you would continue to use virtual machine-based applications. The other reason which I often hear from customers is they need more control over the deployment. Greg talked about control versus flexibility. If you need more control, you would do it on your own. You would run it inside a VM. You would build your own Kubernetes cluster. But if you need more flexibility, you would go to the other end, serverless functions. If you have a need to use some of the OS primitives, the underlying OS kernel drivers or things like that, that's another time when making a use of virtual machines makes sense. Using virtual machines makes sense. Again, this is a slide. Some of the slides that I have in my talk were covered by, were also there in Mahesh's presentation. But I just want to reiterate that point, re-emphasize that point, because it's very, very important for us to understand this. All of our services, including VMs, containers, Kubernetes, serverless functions, they inherit the properties, the design that we chose for OCI. OCI was late into the cloud game. AWS, Google, and Azure were ahead of us. We were the latecomers at Oracle. But that gave us a chance to rethink how cloud should look like. And at Oracle, we have a whole bunch of customers who are running enterprise apps, and they wanted to bring their apps to the cloud, like databases and stateful applications and complex older technologies. So we rethink our design choices. We designed OCI with 4 or 5 key differentiators, which I think we were the first ones in the industry, if I'm not mistaken, that chose this style. So first off, we use off-box virtualization. It's a flat, high-performance network, closed network. What does this mean? It basically, for you as consumers, as developers, what does it mean? It means that there's no more shared infrastructure. We have a separate off-box virtualization, unlike the other cloud providers where they share the networking virtualization, compute virtualization, and storage virtualization on the same layer. We have a separate network. This helps you guarantee network performance, and that is why Oracle offers a performance SLA for all the network performance. Most of the cloud providers don't offer network performance SLA because of the underlying architecture choice that they build their cloud on. The second is we have non-blocking networks. Non-blocking networks, again, leads to better performance, no noisy neighbors, no sharing of resources. It's not a shared services architecture that we're following in our cloud implementation. And then we also use layer 2 networking, which is what is used by things like VMware, rack databases. So we can natively run VMware on Oracle Cloud because we support L2 network virtualization. And then last, RDMA networking. RDMA over converged Ethernet or RoCE. This is another technology which helps us provide extreme performance, particularly in case of HPC applications and things like Exadata, our highest performing database systems. They use RDMA over converged Ethernet, RoCE. So we decided on the architecture using these 3 or 4 things to make sure that we can run existing applications as well as build net new applications. We can cater to workloads like traditional applications, just like e-business suite or any of our database applications that you have written 10 years back. We can run HPC compute applications, compute-intensive applications like run Monte Carlo simulations very easily in our cloud. We can run compute-intensive applications. We can run network-intensive applications. And we can obviously run critical databases. So this allows customers to bring their workloads, whether they are traditional workloads, cloud-native workloads, compute-intensive workloads, as is with minimal rewrite, with minimal re-architecture, and guarantees performance, just like they expected in their, that they saw in their on-premises database, on-premises data centers. I'll talk about flexible infrastructure for a minute here. OCI was the first cloud provider to offer flexible cloud infrastructure. What does that mean as a developer to you, right? You can right-size your applications. Typically, all cloud providers have got something called compute shapes. Shapes are fixed amount of CPU and fixed amount of memory. So you have 2 vCPUs for 4 GB of RAM. That's a shape. The next shape is 4 vCPUs with 8 GB of RAM. What if I need 3 vCPUs and 6 GB of RAM? There's no such shape. So what, as a developer, what you end up doing is taking the bigger shape. And you end up with wasted resources. You end up with oversizing your architecture. That translates to higher cost, wasted resources, wrong sizing your architecture. At OCI, let the developers determine the starting point and the right size their applications. You can select the amount of CPU, you can select the amount of memory for your applications, and then if you need more, you can always scale up or scale down without having to compromise on selecting a pre-selected, pre-sized shape. One of our cloud providers has over 400 instance types. What does that mean? It means as a developer, you have to look at 400 instance types and figure out which one should I use to build my application. We try to make it simple. Again, going back to the keep it simple KISS principle, right? So we make it very simple for the developer to choose the shapes correctly and right-size their applications. This is slightly a busy slide, so I don't expect all of you to see it in the back, but I'll kind of summarize it here real quick. We have compute infrastructure for running all your VMs, whether they are general purpose VMs, whether they are big data, large GPU-driven applications, or high-performance applications running on bare metal servers, or AI/ML compute clustering services running on top of bare metal servers. We cater to all kinds of applications, and we have shapes for everything. And these are flexible shapes. We have ARM as a CPU choice, AMD, Intel, and of course, NVIDIA. So you can pick and choose the right shape for the right application, right? So if you are building a highly compute-intensive application or an AI/ML application, you'll probably look towards the right. You would look at investing in using something with the bare metal shapes, which have GPU support in them. But if you're building a simple web application, running a web server and an Apache web server or a small application, you would probably look at general purpose VMs running on smaller shapes. So let's look at the next pattern, microservices and serverless. Microservices architecture, what are the value prop? Why are people using microservices? Let me set the context here. Right? Microservices are small, independent, loosely coupled applications with bounded context. And that is very important, bounded context, right? You have smaller services, but they need to be bounded. They provide modularity. They provide faster development, faster speed of development. You become more agile. You're able to use DevOps. You can develop microservices independently in smaller teams. They're extensible. They're agile. They're highly scalable. They are resilient if well implemented. And I think you will hear from a talk later in the day from Mark, my colleague Mark, about how microservices and what we think of building microservices, what should we think about bounded context, how do we build a Spring Boot application with a backend as a service. We'll talk about all of that in a later session today. But essentially, microservices have lots and lots of benefits. The key thing here is you need to architect them well. You need to make sure they have a bounded context. You need to make sure you're using the right set of tools and technology choices. And you think about your future state. If you don't think about your future state, you will end up in a massively complex architecture 5 years down the line. So to enable microservices, serverless application, API-driven application, we have a whole bunch of services. And I could have spent the full day talking about each of these services here. But I'll kind of, like I said in the beginning of my talk, I'm giving you a high-level overview of all the services that are available to you, so you have a full, broad picture of what OCI gives you for building applications. So we have a set of Kubernetes services. Greg talked about container engine for Kubernetes, OCI. We have serverless Kubernetes, which we just announced. We have container instances, which is also a relatively new service. These are all applications that you can use to build containerized applications, microservices applications, serverless applications. Oracle Functions is our open source based serverless functions managed service, functions as a service. And then we have supporting services like container registry and service mesh to make sure your microservices can speak with each other. And of course, like with everything else in Oracle Cloud, we give you a choice. If you want to build a hybrid cloud application or a multi-cloud application, we have solutions for those as well. We have the Oracle Cloud Native environment, which is a collection of open source packages which you can develop and which you can use anywhere on-premise in a multi-cloud environment, in a hybrid cloud environment. And similarly, we have a hybrid multi-cloud Kubernetes-based container platform, which is called Verrazano for you to deploy applications in case you're developing hybrid or multi-cloud applications. When you build microservices, you want to make sure that they are API enabled. You want to make sure they have support for streaming, messaging, and all of those things. And we have a series of services, a set of services which help you build microservices. API gateway, API design, API developer portals coming out soon. These are things which will help you build API-first applications using an API-first approach. And then we have streaming, queuing, events, notification services that will help you with integration of those microservices, along with the service mesh. So we have a set of services for building all of those cloud native and microservices applications. And then, like I said a few minutes back, we have a native DevOps experience that we give to our developers. We have a native service called OCI DevOps service, which has build pipelines, deployment pipelines, and source code management all integrated into one platform, which is tightly integrated to the deployment services, whether it's Kubernetes, whether it's serverless functions, or whether it's virtual machines. And then for building your infrastructure stack, for your stack of your, of your architecture that you've chosen, we have a resource manager service, which is basically a Terraform-based, open source Terraform-based service for building your infrastructure, using infrastructure as a code to build your stack. Like I said earlier, if you as a customer or you as a developer have already pre-selected a tool, like let's say you've selected GitLab, or you've selected JFrog, or if you've selected Spinnaker or GitHub, you can bring those in and integrate with our OCI DevOps service. So you could use GitHub for your source code repository management, and you could use the DevOps deployment pipeline for deploying the application that you're building. Our services are modular, and they let you bring your own tool chain in case you have already invested in. This is again a slide which Greg talked about, but I think he breezed through it. So I'll try to take one more stab at it. So where do I run my workloads in OCI? And I think I'll probably revisit the slide. On the left, we say OCI compute is for more control and more operational control of your applications. It's a do it on your own, so to say, offering, right? So you can do anything with it. I do say there that use case is non-containerized workloads. You can actually run containerized workloads and compute too. So that's a change which I'll make in the next iteration of the slide. If you run a Kubernetes cluster, or if you run a Docker runtime in OCI compute inside a VM, you can run containers there as well. It's a lot of more additional work for you, but you can do it. But the idea is, if you want to run anything that you want to build, you would go to compute services and do it on your own. You get full flexibility, you get full control. You can bring in any tool, you can bring in any open source framework, you can bring in any software that you like, build it on your own, get full control. And then we have the Kubernetes services with managed nodes and with virtual nodes. Those are for customers who want to build microservices and running on top of Kubernetes clusters. So you would choose either the managed nodes offering or the virtual nodes offering. And these are for all kinds of containerized applications, not just for microservices. Next, you have container instances, which is for people who don't want to know anything about kubectl and Kubernetes primitives and none of those things. I have a piece of code. I want to deploy it as a container. I want to scale it up, scale it down, scale it out, scale it in, keep it secure, keep it make it very agile. Don't worry about anything. I'm just a developer. I don't care about anything else. Here's my Java code. Here's my Python code. Run it for me as a container. You give us a code, we run it for you in an instance, container instance. And the last one is the extreme end, which is our OCI functions, which is a serverless functions offering. One of the things which we have done differently is, it's an open source based service based on FN project. It allows you to write functions in any programming language, and then underneath, we deploy them as containers for you. So what that means is, as a developer, you can pretty much create a function using any language of your choice. In fact, if you want to use a shell script to write a function, not that I recommend doing it, but if you want to use a shell script to write a function and package it up as a Docker container and give it to us, and we'll run it, spin it up as a serverless function. These are event-driven applications which get triggered when the event trigger occurs, right? So these applications are typically meant for API implementations, event-driven code execution, and short-lived functions, short-lived applications which run when they need to run and then shut off. So we spin up a function, we run them, and then once it's done, it's taken down. So it is economical, it is scalable, it is the least operational overhead for you as a customer. And then again, I talked about this point earlier, but most of our services in the cloud native space are built on open source, upstream open source, right? Our managed Kubernetes service is built on upstream Kubernetes source code. We have the Terraform-based resource manager service. We use Docker, we use Spark. We have cloud events. Cloud events is a CNCF standard for the event service. The whole CNCF ecosystem wants events to be standardized using the cloud event specification. And we adopt that. We have serverless functions, which are again open source. OpenSearch is one of our newer services, which is again built on open source. So we have a whole bunch of services which are all built on open source. We built added tooling to it to make your lives easier. And then, of course, you can bring in any technology choice that you want. You can integrate with any of the open source technologies that you're already using. We support all the communities, the common communities, the Cloud Native Computing Foundation, the CDF, the Linux Foundation. We are platinum members of CNCF. So we actively contribute code to these communities to help Kubernetes and other CNCF applications get better as well. So we take your feedback, we get your inputs, and we contribute it back. We develop the code for it and contribute back to the CNCF projects. So let's talk about the next pattern. Emerging AI, emerging technologies. It's no longer emerging. I should probably reword it. But you get the point. It's basically the newer technologies, AI, ML, 3D, Web3. These are important. And we want to meet the developers where they are in terms of what they're building. So Oracle has services for enabling the emerging technologies pattern as well. So when it comes to AI and ML services, we offer a comprehensive offering of AI and machine learning services that cater to three personas. They cater to the data scientists, they cater to the developers, and they cater to the business application users. So starting with the lower part of the slide, first of all, we talked about the unique benefits of OCI, the off-box virtualization, RDMA over converged Ethernet. All of that is inherited by our AI and ML services. So we have an advanced GPU and CPU architecture with RDMA over converged Ethernet networking. So we have no shared networking, no shared storage, high performance storage, high performance networking, and then of course, CPUs and GPUs for compute. Storage, networking, CPUs, GPUs, all of them are very important things that matter to all the AI and ML services. On top of that, data is important, right? So obviously, AI and ML work, the better support you have for database and data management, the better your AI services are. The more data you have, the more better performant your AI services are, ML models are. So we have 3 or 4 things in that next layer. The OCI data science service is a service targeted at data scientists. It is meant for building machine learning models, training those machine learning models, deploying those machine learning models, and then managing those machine learning models. So data scientists would typically build a model and then give it to the development teams for them to use that model and deploy it as part of their applications. The next set of services that are listed on the slide are the database services. Think about it. The closer you are to the database, the better performance you get, the minimal round trips you have between the database and your AI/ML interactions. So machine learning is natively embedded in Oracle database. We use it extensively in our Oracle Autonomous Database. And it is also part of MySQL HeatWave ML implementation. Recently, we announced that. So we have those 2 database services with machine learning natively included in them. And then data labeling is another important service which you need to label your images, label your text, or label your objects classification. When you're detecting objects, doing object classification, you want to label them. So we have a labeling service so that you can the models can work efficiently. The machine learning models that you build can work efficiently. They can be trained well, they can work better. And then on top of that, we have AI services for digital assistant, speech, language, vision, document understanding is one of our newer services, anomaly detection, and OCI forecasting. And as you know, Oracle has the infrastructure layer, the platform layer, and then we have also got the SaaS applications. All of these applications, for example, the Oracle Digital Assistant is used by our SaaS applications to provide conversational interfaces for those SaaS applications. So we cater to all the 3 demographics, all the 3 personas, whether it's developers, data scientists, or business application users. So let me talk a little bit about our AI services. And there are several AI sessions going on today, so you can get into deeper dive into any of these areas today or the next few days. But we have provided pre-built customizable AI models for language service, for anomaly detection, for speech detection, for vision service, for forecasting, and for document understanding. You can simply take these services, use REST APIs and SDKs, and embed intelligence into your applications that you're building, whether it's cloud native or any other application that you're building. These are ready to consume pre-trained models. And of course, you have the choice of bringing your own models, so they're customizable. And there's no data scientist required here. You don't have to work with Jupyter notebooks or with Python to to create a model, to develop a model, to train a model. These are pre-trained services which you can directly infuse into your applications. Let me take a minute to talk about Oracle Digital Assistant, which was one of the first AI services that Oracle built probably about 5-6 years ago. I may be wrong on the timing, but it's one of the older services, more mature services. So what are digital assistants? These are basically chatbots, AI chatbots, artificial intelligence chatbots. So think about Siri, think about Alexa. What are Siri and Alexa? These are consumer chatbots for consumer world. Equivalent of that for the enterprise applications, we have something called Oracle Digital Assistant. Oracle has been heavily involved in the enterprise space. We have all the enterprise app support and everything. So naturally, it made sense for us to focus our energy on the enterprise application space rather than the consumer side of things. So when it comes to chatbots, on the right you see several channels. Your channels can be voice channels, they can be text channels. It can be SMS, it can be WhatsApp, it can be a voice assistant like Siri or Alexa, things like that. So you have several channels that you can communicate with the chatbot with. On the left side is any application that you have. Let's say I want to talk to my IT support team, or let's say I want to talk to my payroll application using a chatbot. So I have those SaaS applications which are for supply chain management, ERP, payroll, HCM, customer experience on the left. These are already pre-built SaaS applications. I want to enhance the user experience by providing a chatbot interface using Siri or Alexa or simply a Facebook Messenger. I want to chat with them and submit my expense report. That extension is you can easily do that using Oracle Digital Assistant. What Oracle Digital Assistant does is it provides you with skills which are listed in the middle for all of your SaaS applications, whether they are sales apps, whether they're expense apps, whether they're loyalty apps, whether they're inventory apps. We have developed skills for you to use, which can be exposed via conversational channels using ODA. I don't have a browser here, but if you want to try it out, and this is probably, I'm sharing some early information with you, a new thing. The bit.ly link there, we have a chatbot called RT. RT is a chatbot for our documentation. I'm pre-announcing it, kind of letting you play with it and see with it before we open it up for wider audience. But there's a chatbot which you can play with. You can ask the ODA documentation questions about things like, tell me about SQL dialogues, tell me about intents, tell me about anything about ODA. Anything that you want to learn about ODA, you can ask a chatbot and it can reply to you. Another service which is gaining a lot of attention and a lot of mindshare among developers is our MySQL HeatWave service. It is a single unified service for transactional database applications, for analytics, and for machine learning. This is something revolutionary in my mind. I think Mahesh also mentioned he likes the service a lot. What that means is basically what we have done is we have a MySQL HeatWave in-memory application in front of the database. It's called MySQL HeatWave. It's a massively scalable in-memory engine which accelerates the SQL queries and analytics for you, and you operate on the same database. Typically, what you do with the database, like in the past, what you would do is you have a transactional database, you have to extract, transform, and load, and create another database, and then perform analytics on top of it. Here you have analytics and transaction processing all in the single database, and all in near real-time analytics. So you don't have to spend cycles moving the data, extracting the data, transforming the data. And one of the key things that we are doing differently from the industry is we have made this service available not only on OCI, as you would expect, but it is also available on AWS as well as Microsoft Azure. So we let the customers, we are meeting the customers where they are. So if you want to try it out, feel free to try it out on AWS, Microsoft, or on OCI. It's the same service available on all the 3 platforms. Of course, on OCI, you'll get a better price performance benefit than the other cloud providers. And most of your MySQL applications, like your applications which you have written for the Aurora database on AWS, can be moved over to MySQL HeatWave as it is without rewrite. Let's talk about visual and low-code applications for a minute. So like I said in the beginning, as developers, we don't always have to build the most latest trendy application. Don't always lean towards serverless and microservices architecture if it doesn't make sense. If you are simply converting a Excel web sheet into a web application, or if you are simply doing CRUD data operations, input, output, read, report, analytic, basic stuff, productivity applications, you probably want to look at low code as a solution. It's easier, very easy to learn, very quick to build applications, very minimal coding. You can build applications and release them faster time to market, and then of course with minimal cost. And in addition to all of these benefits, maintaining these apps is also a lot more easier. So in Oracle Cloud, we have 2 choices for you when it comes to low-code application development. One is Oracle Apex, which is part of the database, Oracle database. It's a low-code application development platform which comes with the Oracle database. It's also offered as an OCI service. It helps you build modern data-driven web applications and productivity applications. You can simply take a spreadsheet, import it into Apex, and convert it into a web application and become like a hero in your group within an hour or 2. It's so easy to use. I've used it multiple times. We have several applications within Oracle for which we use Apex. The second is an Oracle Visual Builder platform. It's a visual drag and drop style of application development using JavaScript behind the scenes. You don't have to write much of JavaScript code. It's mostly visual drag and drop browser-based building applications. Visual Builder platform is primarily targeted at extending Oracle SaaS applications, but that doesn't stop you from building native web applications or mobile applications. You can build them using Visual Builder platform. So like I said, Apex is a low-code application development platform. The 3 key things about this, which I like about this platform, is there's no software to install. It is all declarative. There's no code generation. Everything happens inside a highly efficient database engine. So unlike the 3-tier apps where you have a web tier, application tier, and a database tier, all of your application runtime and database are inside Oracle database. So it's much more efficient, much more faster. It is targeted for citizen developers, but if you want to, as a data scientist or as a professional developer, you can write SQL code and use some JavaScript and build even fancy applications. In fact, in Oracle, we have our employee lookup directory for over 130,000 employees, which is built on Apex. So it can build not only small applications, but it can build massively complex applications. It's highly extensible using REST APIs. And there's an odd server which helps you build REST APIs for anything that you build. So it's highly extensible. You can integrate it with some of the traditional Oracle apps like eBusiness Suite. And it runs on-premise as well as cloud or wherever you want to run it. This is a very interesting story. I worked with this company called Peak Solutions 5 years back. And we asked them, when we were going to announce the Apex application development service, I asked them to do a study for us, a time and motion study for us. And the time of motion study was basically building a React.js application with faceted search and interactive grid, and build that same application in Apex, and build that same application using React.js, the JavaScript framework. So we asked Peak Solution to do a study for us, a third-party company, completely independent, no say in us from our side. What they did in turn, they hired a developer with 25 years of development experience who knew how to write code in JavaScript, who was very familiar with React.js, but had zero experience with Apex. We asked him to build the same application using JavaScript and with Apex. It took him, he was able to develop the same application 38 times faster with Apex and with 20x less code. And if you don't believe me, the URL on the slide has all the details, including the lines of code, a detailed 50-page report, which is written by that developer about his experience building an application using React.js versus Apex. The next platform which I want to talk about is Oracle Visual Builder Platform. So Oracle Visual Builder Platform is primarily targeted for extending SaaS applications, but you can build native mobile apps and web apps using this platform as well. Behind the scenes, it uses JavaScript. It is all JavaScript. But you as a developer use drag and drop style for building applications. The key use cases is extending SaaS applications, doing CI/CD. So we do have OCI DevOps service for doing building your cloud native apps. But we also have another choice for you, Visual Builder Studio, which helps you do CI/CD and some of the stuff that DevOps service does. So what are the key capabilities for this service? It's a cloud native service. It's completely integrated with SaaS applications, Oracle SaaS applications, which means you don't have to worry about the look and feel. You don't have to worry about the security integration with SaaS applications. It's the same single sign-on. It's the same identity and access management solution that you'll use with this service as well as with SaaS applications. And it is extensible. And it's easy to use. It gives you the flexibility. Most companies who use SaaS applications cannot extend them. This is one of the differentiators for us. We can extend them. We can go out of the box and do build some extensions for you using this service. Here's a high-level architecture of this service. There are two parts to the Visual Builder platform. One is called the Visual Builder Studio service. The second part of the platform is called Visual Builder. Visual Builder Studio is the design and development service, which is the top part of it, the development part of it. Visual Builder is the runtime part of it. And I know our naming is not the best. We are not the most creative at Oracle. But we have two parts in the Visual Builder platform. One is the Visual Builder Studio, which is the development design time service. And then you have the runtime service, which is called the Visual Builder Studio, which is called the Visual Builder service. You can build applications in Visual Builder Studio using Git repositories, doing CI/CD, using wikis, doing code reviews, doing task management, all of that in a visual environment. And then once you have built it, you can deploy and run those applications inside the runtime service called Visual Builder. And of course, all of these are REST exposed, and you can highly extensible applications. To summarize, we have a complete cloud platform which is purpose-built for developers. We want you to pick up the right tools and services for building the right applications. Not every application needs to be a cloud-native serverless application. You have choice of building virtual machine-based applications, low-code applications, and of course, cloud-native serverless applications. You can use emerging technologies like AI, ML, blockchain, Web3, all of those things. But before you build the application, think about what I said in the beginning. Don't let technology be the first thing driving your choice. Think about the business outcome. Look at your business requirements, look at your use cases, and then choose an architecture style that meets those requirements. Keep it simple, build as much automation as possible, and you shouldn't always start with one technology trend. Think about the future state of your applications. We have several resources for you available as a developer. We have obviously documentation like every other product has. We have free trainings for all of the OCI services that I talked about at a high level. We have Architecture Center, which has got reference architectures for all kinds of patterns that we talked about, whether it's VM-based apps, whether it's emerging technologies, whether it's AI apps, ML models. We have reference architectures ready for you to use. Some of them have automation tied to it, so you can deploy those architectures in OCI as well. We have a one-stop shop called developer.oracle.com, which is our developer resource center, which has got tools, tutorials, hands-on labs, videos, recordings of this event. All of that will be posted there. And of course, we have the community platform where you can ask questions, and we also have a Slack channel which you can engage with us after this presentation. Thank you for taking the time today. I hope you found the session useful. If you'd like to give me some feedback, here's the QR code. Look forward to meeting you all in person, spending time with you after this presentation. And let me know if I can answer any questions after this session. Thank you.